Hello guys, back to you again. So we were talking about molar masses and how to calculate them. And I give you example of the glucose. This is another example of another molecule here. You can see C2H6O, C2H6O. And to calculate the molar mass of this molecule, you basically get the numbers from the periodic table, the masses from the periodic table for each cell, and then multiply by the subscripts. And here you can have 2 times 12, 6 atoms of hydrogen, each one is 1.008, and then 1 mole of oxygen in 16 grams to get these numbers. And then after this, you can add them together to get how many grams are is 1 mole of this molecule. Um, More problems. Let's get another example here to actually explain it. And we will be using the salt example. So here it says a box of salt containing 737 grams of NaCl and looking for how many moles of NaCl are in the box. So I will go into here so I can actually help you explaining this. So our inputs are, or the given, oops, the given here is basically um, 37.7 gram NaCl. And the needed is how many moles are in there of NaCl. So first thing to think about is to look at the units. So you can figure out how are you gonna figure this out. So grams here and moles here, then it's so obvious that you would be using the molar masses. So the first thing that you would need to do is actually calculate the molar mass of NaCl. So molar mass of NaCl equal, so we have one atom of Na, each one is exactly 22.99, okay, and we also have one atom of chlorine, each one is 58.44 grams. Grams NaCl, and here gram sodium, and here gram chlorine, and then equal, you will get a number of around oh, this number is not right actually, sorry. So let's get the eraser. This number here is the total actually, and then here you can get the number is 35.45. Okay, this is from the periodic table. Again, this one here and this one here, just from the periodic table. I didn't do anything yet. And then now we can have an equality that can says that 1 mole NaCl actually has the number here, the results will be 58.44 gram per mole NaCl. So 1 mole NaCl has 58.44 gram in NaCl. And now we have an equality. We can absolutely, very easily have a conversion factor in ACL. And here we can have 5.44 gram in ACL. Or the opposite, 58.44 gram in ACL and divided by 1 mole NaCl. And now we basically ready to apply our given to look for our needed. So we can start here by our given is 0.7 gram NaCl. I'm just taking this one here. Times we need to get rid of gram NaCl, which is here. So I will just use that one here. Times 1 mole NaCl divided by 58.44 gram NaCl. And then from here we will cancel those units here and then time to try to figure out, is this the unit that we actually need? The one that we have now is mole NaCl. Is this the one that we look for? Yeah, that's the one that we look for. So equal, you do your calculations and you will find that this is equal to, after you do your results, and it's equal to 1.26 mole NaCl. That's it. All what you need is just to organize your thoughts. And after this, it's just the first step ever is to organize your thought. The second step is to look at the given and needed and try to make connection between the units. And then after you get connection between the units, then it's very easy after this to follow the steps. So all of this we discussed before in class. The second thing that we will be discussing now is, so here is from the PowerPoint presentation and you can see all what we did, and then the result is 12.6 in ACL. Mole-to-mole relationship is another topic that we discussed and we need to review. So going here, you can see. So we did mole to atom, we did mole to molecule, we did now mole to grams, and now we will be doing mole to mole and in the same time molecule to atom. We actually did molecule to atom at the first video, so but we will do it again. So mole to mole, now how to use the mole to mole calculation. So get an empty screen here. So mole to mole. Actually, they also call it mole to mole ratio. Example here. So in the chemical, let's see here. So as you can see here, this is an balanced equation, and you can see here that This is a 2 mole of Fe plus 3 moles of sulfur, and you get 1 mole of iron 3 sulfide, or Fe2S3. Again, these are the amount in moles, and you can see the grams are totally different. So moles is another unit. Um, so we can say also that 2 moles of Fe is reacting with 3 moles of sulfur to make 1 mole of Fe2 is 3. And from there, we can actually have a relationship between either the Fe and the sulfur, or the Fe and the product, or the S and the product. So you can actually play around using the mole to mole ratio to make a connection between the reactants and the product, or even one of the reactant and one of the products. It depends. So you can say here that 2 moles of Fe equal 3 moles of S of sulfur. You can have 2 conversion factors. Same thing here. You can say 2 moles of Fe equal 1 mole of Fe2S3, and you can have a pair of conversion factors. Same thing. You can say 3 moles of S sulfur has 1 mole of Fe2O3, and so on. So this is very important step because you actually can move around in the equation. Whenever I give you an equation and ask you to figure out in how many grams are produced by specific reactant, you can actually play around between the reactant that I will mention and the product that's mentioned. We will see some of the examples here. Here you can see that this is an equation. You can say that 3 moles of hydrogen actually equal to 2 moles of NH3. Or you can say 3 moles of hydrogen is equal to 1 mole of nitrogen. Or you can say 1 mole of nitrogen is equal to 2 moles of NH3. Um, so if we're trying to figure out the answer for this one, we can actually say it's between the hydrogen and the nitrogen, which is here. So we can say try to find all the hydrogen, 3 hydrogen. So this one has 1 mole of hydrogen, so we cross, we don't need. This one has 3 mole of hydrogen. Okay, this one has 2 mole of hydrogen, we cross. So we have to check also the nitrogen. So the nitrogen here is 1, so it's B, the answer. If we go to the second question, it's between the hydrogen and the NH3. So we have to basically find 3 and 2 before the hydrogen NH3. So this one has 1 H2, which is wrong because we have 3. Here, this one has 3 H2, which is right. 2 mole of NH3, which is right. This one is right. This one is not correct because it's using 3 moles of nitrogen. And the question is asking about hydrogen, not nitrogen. So this is basically how to do it. In the calculation processing, so here we have how many Fe2O3 is produced can form from 6 mole of oxygen. So the relationship now between the oxygen and Fe2O3. So we can have an equality state that 3 moles of oxygen, it's again mole to mole ratio, equal 2 moles of Fe2O3. And then we can have conversion factors and then apply our given and needed. I'll try to do it in here so you guys can see it quickly. So it was, where is it? I think it will have to be in another video so we don't actually interrupt it. So I will do it in another video. See you later.